The following functions is given. I guess there are given. List all rational zeros that are possible according to the rational zero theorem. Use synthetic division to test several possible rational zeros in order to identify one actual zero. Use the zero to find all the zeros of the polynomial function. Okay, so first we are going to do rational zero theorem. Okay, so the rational zero theorem, which we just went over, so in this case the P would be from the 20, and the Q would be from the 1. Okay, so first let's figure out what our P's are. So P, we're going to split the 20, which we can do 1 times 20 is 20, 2 times 10 is 20, 4 times 5 is 20. So we have 6 different possibilities there for the P. Then let's do the Q. Well, the Q is just 1, so it's just plus or minus 1. That's all we get for that one. Then we want to find the P over Q, which is going to be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, and plus or minus 20. And then we put all that over plus or minus 1. Now, basically, all that means is that all of the denominator is going to cancel out, leaving you the numerator, which is just plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, and plus or minus 20. 1, 2, 3, 4, 5. Oh, I forgot 10. And plus or minus 10 goes right there. Okay, so we have all our possibilities there, right? Now, based upon this, so we found all the rational zeros. Then we're going to use synthetic division. Now, I kind of cheated. You should probably start with like a 1 or a 2 whenever you're doing the synthetic division. But in this case, I actually know what the answer is. I cheated a little bit. That's okay. Normally, you'd have to, literally, if you wanted to be thorough, you could do synthetic division with plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20, which means you'd have to try 12 different synthetic divisions. So I worked ahead a little bit on this one. So basically what this means is we are going to set this up in synthetic division. So synthetic division, you're going to rewrite the original polynomial, the function, but without with just the coefficients. So it's going to be a 1, negative 5, negative 4, and then positive 20. And you don't have to write the positive. It's just understood to be positive if you don't write it. So then you're just going to write the 20. Make sure you have enough space in between them. Okay. And then you're going to do synthetic division. Then what you want to do is what you're dividing by. Now, I'm going to divide by the 2's. It's a good place to start. I'm going to start with a negative 2. Okay, and what I'm going to do is I'm going to bring down the 1. Oops, didn't leave myself enough space there. Hopefully that'll be good. Yeah, let's do that again. So I bring down the 1. All right, so then I say negative 2 times 1 is negative 2, and negative 5 plus negative 2 is negative 7. Then I say negative 2 times negative 7 is positive 14, and positive 14 plus negative 4 is a positive 10, and then I say negative 2 times positive 10 is negative 20, and I say negative 20 plus 20 is a 0. Okay. Now, you could keep on going at this point, but once you get down to a second power, you can stop. And what I mean by that is, when I divided by this negative 2, basically, what that means is that I started with a 3rd degree polynomial. Now I'm down to one lower, which is a 2 degree polynomial, which now you can actually just factor the rest. And let me turn this back into another polynomial. So this is going to be squared because it used to be cubed, and then minus 7x plus 10, right like that. Okay, and what I factored out would have been something like that. Okay, so basically just kind of imagine there's an x there in front of it, x minus 2. From here, we're going to factor the second one. So we keep the x minus 2. Square root of x squared is x. Going to put it in the first place of both. It ends in a positive, which means they're going to match. Middle terms a negative, which means they're both negative, matching negative. And I'm looking for two numbers that I'm going to multiply together to give you a 10, that if I add together give you a 7, which means it will be a 2 and a 5. Okay, and now I have all three of them. And that I can set equal to 0, and I can solve. right? So that means x minus 2 equals 0, therefore x is equal to positive 2. This first one here, it's the opposite sign here, so this is actually going to be the opposite sign, so that's going to be a plus, which means this is a plus. Got a little ahead of myself there. And that means that's a negative. The other one's going to be x minus 2 is equal to 0, so plus 2, cancel, cancel, and x is equal to a positive 2. And finally, we have x minus 5 is equal to 0, plus 5, cancel, cancel, x is equal to positive 5. And there we go. It says, use synthetic division to test several possible rational zeros in order to identify one actual zero. Use the zero to find all the zeros of the polynomial function. So if you start with a third degree polynomial and you find the first one, as long as the rest of it's easily factorable, you can just solve the rest of it using a different method. So for instance, I can do the same thing on this one. And I did work ahead a little bit on this one as well, just because I don't want to go through dozens of different possibilities. Okay, so first I will do the P and the Q. So we do have a P here, right there, and we do have a Q there, right there. Okay, so let's find all the P's. So we have a 63 there. So we have 1 and 63, that's a possibility. Well, what about 3 and 21? That's a possibility. What about a 7 and a 9? That's a possibility. And that looks like that's it. So we have 6 different possibilities, and they're all plus and minus, 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 plus and minus. Okay. Now, what about Q? Okay, so we also want to find Q. So Q, we have to make up a 5, which is just 1 times 5. And again, plus and minus, plus and minus. Okay, now from there, we're going to find P over Q. So what do? We have a plus and minus 1, plus and minus 3, plus and minus 7, plus and minus 9, and we have plus and minus 21, and we have plus and minus 63. And what about the Q? Well, the Q is plus and minus 1, plus and minus 5. Okay, now we want to simplify this as much as possible. So we're going to say plus and minus 1 over plus and minus 1, plus and minus 1 over plus and minus 5, plus and minus 3 over plus and minus 1, plus and minus 3 over plus and minus 5, plus and minus 7 over plus and minus 1, plus and minus 7 over plus and minus 5, plus and minus 9 over plus and minus 1, plus and minus 9 over plus and minus 5, and we have plus and minus 21 over plus and minus 1, and we have plus or minus 21 over plus and minus 5, and then we have plus and minus 63 over plus and minus 1, and we have plus or minus 63 over plus or minus 5. So those are all the possibilities. You have several of these where the denominator is going to disappear, so those are going to simplify. So what I mean by that is you can easily see like this denominator is going to go away, this denominator is going to go away. All the ones that are divided by the 1, they just go away. So all those go away, just leaving you the numerator. But that still means you're left with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you're still going to be left with 12 different possibilities, which is a bit much. Again, I would usually start, 1s and 3s, the smaller numbers first. Okay, so let's do some synthetic division. So we just rewrite the original function, but without the variables. Now, if there are holes, for instance, if it went from x cubed, x squared, maybe it had x cubed and went straight down to x to the first power, you'd have to put a 0 in for the x squared. So you do need to put placeholders there, just like whenever we were doing long division of polynomials. You do have to have placeholders if you are missing terms. Okay, now from there, I'm going to do, let's do a 3. Okay, so let's do 3. So we're going to bring 1 down, which is a 5. Then we say 3 times 5 is 15. We say 15 plus negative 7, or negative 7 plus 15, which would give me a positive 8. We say 3 times 8 is 24. 24 plus negative 45 is a negative 21. 3 times negative 21 is negative 63, which leaves you a 0 there. Okay, now you had a third degree polynomial. Now we're down to a second. We decreased it by 1 degree, so we end up with 5x squared plus 8x minus 21. Okay, And what we had in front of it is we had an x minus 3, the opposite in front of it. Okay, so now we want to factor this out. Now you could try, you could do synthetic division again if you wanted to. In this case, it's not actually going to make it any easier to do the factoring, but a negative 3s I know is another one that's going to work on this. But regardless, let's continue this like with factoring. So if you want to do synthetic division, you can continue to do that, or you can do factoring. Oftentimes it's easier to factor, but in this case it probably would just have been easier to do negative 3, the opposite of 3. Or you could just try to get in 3. Again, you can have repeats of all these, so even though you have 12 different possibilities, some of these you might have to repeat, so you could try negative 1, and if it goes in once, you could try negative 1 again. If you try positive 3, you could try positive 3 again. That's how synthetic division works. Sometimes you can try the same one twice, so that can be a little time consuming. Anyways, okay, so let's do let's factor this. So we say 5 times negative 21, and that'd be negative 105. Okay, and what we're looking for is two numbers that you can multiply together to get a negative 105 that if you add together would give you a positive 8. So they're going to have opposite signs. So you have 1 and 105. That's obviously not going to work. 3 and 35. That's also not going to work. It's going to be more even, right? They're going to have to be more even numbers. So you have 5 and you have 21. The difference between that's not going to give you 8. You can have a 7 and you can have a 15. The difference between 7 and 15 is actually 8. Now, since 8 is positive, you know the stronger one must be positive and the weak one must be 7. Okay, so we found them. All right, so we're just doing some side work right here. So we are just going to keep the x in the first place of both. It ends in a negative, so they're going to have opposite signs. And we're going to have a negative 7, and we're going to have a positive 15. Now, since the leading coefficient was a 5, we are going to divide by 5. Okay, now if it does reduce, for instance, the first one did reduce, so it gives me x plus 3, right? 15 divided by 5 is 3. We have x minus 7/5. We put the 5 in the front. That gives me 5x minus 7, right? And then we are done. So that whole entire thing is now equal to 0 after we're factoring, which means we set the factors equal to 0 and solve. So we say plus 3, cancel, cancel, x is equal to 3. Then we say x plus 3 equals 0, minus 3, cancel, cancel, x is equal to negative 3. And then we say 5x minus 7 equals 0, plus 7, cancel, cancel, 5x equals 7. Divide by 5, cancel, cancel, x is equal to 7/5. So it looks like we have the answers. Now technically you should probably write the answers in set notation like this. Now notice that technically I didn't put these in correct order. I didn't put them in correct order, not even technically. That's okay. I'm using set notation. That's a list. That could be red, green, or blue. It could be cars, trucks, vans. It's just a list, right? This is not the same as interval notation where that is required that you put the smaller one on the left and the larger one on the right. So this is different with set notation. So technically I ought to do the same thing over here. It looks like I have a negative 2, I have a 2, and I have a 5. In this case I did it in order, but you don't have to. It's not imperative that you do it in this case.